Hey guys, good evening for the very last time. This is the last video for AP Physics, Electricity, and Magnetism, and we are here to give you some last minute tips and tricks and just to celebrate all the hard work that we've done these last, gosh, I don't even know how many weeks, since like March 25th. My name is Kristen Gonzalez Vega, and I am in Frisco, Texas, and I have Roger with me as always. Roger, hi.
Hey everybody, welcome. Thanks for joining us for this last hurrah, sending you guys off last weekend before the exam. So excited to be here.
Okay, so first thing we want to say is thank you so much. I'm going to share my PowerPoint here with you guys. We have enjoyed so much like being here every day and having this kind of sense of normalcy. I don't know about you, Roger, but when I first found out we were going to be doing this live every day, it's kind of scary knowing that everyone's going to see it, and if you make a mistake, then it's just out there. And I was like, why? If they can go back and watch it later, why are we live? But it's been so nice to have this interaction live and knowing people are watching it at the same time. So what we're going to do tonight is we are going to give you some specific tips and tricks, but I also want to open it up for questions. So if you have questions, there are two ways you can get them to us. You can fill out the Google form here that I have created. There is the QR code and also there the shortened, not very short, but shortened link to that Google form. You can also send them on Twitter if you want to go that route. And my Twitter is @APGVs. So either of those two ways, you can send us some questions, and I'll kind of come back to this and put this back up a few different times. But I'll leave it up there for just a second if you guys wanted to scan. So what we're looking for is we're looking for questions that are generic test taking questions. So like test taking tips, or what if I have this kind of question that I want to answer, and what's the best way to do this? So this isn't, can you show us one more time that Gauss for a non-uniform charge? Like these are not specific like physics C go over content. These are like general physics C taking the test kinds of questions. Okay, so we'd love to hear from you guys and let us know what you want to know about the test. Roger, you want to add anything in there?
Yeah, well, I did. Let me see. Are you still sharing? Okay, there you go. Perfect. So you're sharing. Yeah, I did want to add something. I think, you have worked so hard all year, and all we want you to do is just kind of glide into this Monday with everything that you've learned and apply it, because you're there. You're there, and so we just want to kind of get you moving through and out the door, as it were.
Yes. This is not to create more stress on what you don't know. That's why we don't really want to get into concepts. We want this to be that you're feeling confident going into Monday, like you're going to rock it, because we know that you are. Before we kind of go into our specific tips and tricks, these are those 5 steps that you guys want to make sure you're doing before the exam. So you should have by now gone on to that exam demo and tested out how you're going to upload and the different ways that you can. Completing that checklist for exam day, confirming your email address, and locating your e-ticket, which I think you can also find on your College Board account. So it should be in your email, but I think you can also log into your College Board account and find those. And those should be sent out 48 hours before, which I assume you should already have it. Roger, have any of your students told you they have theirs already?
No, they have not, but I'm going to be making lots of phone calls this weekend, so I expect to hear that they have. They're supposed to show up
Yes.
2 days before the exam.
Okay, and that you check in 30 minutes early for that exam, because you got to fill in that personal information that you see on that demo, and we don't want you to log in and you see that clock on the bottom that there's 30 seconds left before the exam starts and you've got to put in your information and you're already behind. So get in there nice and early. So we have 2 kinds of questions this year. So we've got what we call the QQT problem. That's that qualitative quantitative translation. And if you guys took AP Physics 1, which I know a lot of you did, it's kind of those questions where you're asked just in general, kind of what happens to this, and if you change this, and then it gets a little bit more specific now. If you had this equation, like maybe something's right or wrong about it, and you have to pick things out. So it goes kind of that qualitative, just what's going on, versus quantitative, here's some equations. And so if you are given an equation, so that I've kind of seen, at least in AP Physics 1, right? Like we don't know exactly what this is going to look like, but we're modeling it off those AP Physics 1 style questions. And what kinds of things I typically have seen is that one thing is you could be given an equation. So, you know, students come up with an equation to model the situation, blah, 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 right? And you're given this equation. I did an example here for Q enclosed for a uniform non-conducting sphere. And so if you're R less than R, I have the equation that Q enclosed is equal to Q times R squared over big R squared, where like Q is the total charge of the whole thing, little r is at any radius, and big R is the big radius, right? So could you pick out something that was right with an equation? Can you pick out something is wrong with the equation? What you really want to look at is where those things are in the equation, like what things are in the numerator, what things are in the denominator. Is that a direct relationship? Is that a square relationship? And being able to pick out something that's good or something that's bad if needed to. Also, if you are given a function for something, that's probably going to involve calculus, right? So not actually calculating the shear necessarily, but still having to explain a calculus. So if you're given a function like on Roger's problem on Monday, where we had the electric field as a function of the position, and you had to look at whether it was right or wrong, the different places where that was modeled. Again, you could take the negative integral of that and use that potential function. So if you're given a function, chances are you're probably going to be using some calculus. Do you agree, Roger, with that point?
Yeah, thanks. Thanks, Kristen. I was going to say that's absolutely right. Can I show them a particular problem that I think is something that they might want to look for? If you'll throw it over
Yeah,
here.
let me stop my share.
Okay.
Go ahead.
All right, good. So what I wanted to show you guys was, this is a problem from last year's test. It's the 2019 test. And you can almost see, you know, Kristen and I we do this for a living, you know, we study these things to try and figure out what's going to go on. And what you see is this test starts out like many other problems that you've seen, but then it starts to ask some really interesting questions. And we did this one earlier in the year, but here's the one I want to focus on. First, they start out with a symmetric problem. And, you know, almost all your E&M problems are symmetric because that's the way that the math works. And we want you to understand this concept of symmetry. But then they make it asymmetric. Look at that. And so that's a clue for you that something's wrong, something's gone amiss. And you can kind of start to spot these. And now look at the question. Is there a Gaussian surface that you can use for an expression? Well, you know that every time you've done Gauss's law, it's been about a symmetric problem. So they're kind of, you know, laying it out here for you. They're saying, can you still use Gauss's law? So more this year than the actual, you know, do the math, what we're expecting to see is more about what's right with the math and what's wrong with the math. So a problem like this, a problem like the bead through the sphere problem that just got published this year, those are what we're really looking for, that kind of thing. You think, Kristen? Oh, you're muted.
Thank you. Yes,
Yeah.
I think that's a really good problem to look at. And that one, even at the end, had those two equations, right? And you had to pick out which of the two was the correct equation. So
That was a slightly different one, but that's the same idea of looking at the geometry of that.
okay, so if we look back at here, then some other things that you might be asked to do on a QT problem is to examine a graph, right? So we're not drawing graphs, but you still have to know what's going on with a graph. And there's always a kind of three things that I tell my kids they should be looking out for. Does the slope stand for anything that's significant? Does the y-intercept stand for anything that's significant? And do you have any asymptotes that might be significant? So there's another problem that's available for you guys that's on the AP Classroom too. That's one of the practice problems that you can see. And we didn't do it, but it's a charging of a capacitor, and you have this graph of charge versus time. And there were some different questions that went along with it, but you were looking at those things, right? Like what would the initial slope of a charge versus time mean? right? That's that initial current. Charge divided by time is current. So looking at what is the slopes, what are the asymptotes, areas that I didn't put on there too. So areas can be significant. Always looking at a graph, and do any of those things mean anything for that situation? Roger, what do you think about graphs?
I think we definitely have to focus on, yeah, I'm expecting one graph on this year's test. I would think it was going to be there. Kristen, we have some responses
Oh,
for our
good.
forums. So I wanted to kind of go through some of these. And so one that they have is, what resources do you recommend that we have right next to us as we're taking the exam, in addition to the formula sheet? So I was going to say the formula sheet, which I love. What can you think of anything?
I would say as little as possible. These 45 minutes are going to fly by, and trying to rifle through your notes, if you're making one page for every section, you are going to burn through that time. So I think as little as possible. I'm going to tell my kids, and I'm going to tell you guys the same thing, make one page, front only if possible, but don't make the writing so tiny like you're cramming 10 pages into one page. Find just one page of important things. Maybe it's a derivation that you spend a ton of time wasting that you may still want to know a relationship for, right? Those charging a capacitor or discharging a capacitor, or significant graph. But I would keep it as little as possible. What do you think, Roger? What are you telling your kids to have?
I would say that's the same thing. Think about if you have one or two things that stuck out in your mind, and every time it came up, you were like, oh yeah, that's good, and that helps. Maybe you have that out, but there probably aren't more than that. Okay, it's probably, again, I think Kristen's idea of one page is the way to go. Kristen, we have a question about, and I'm not surprised this showed up. It was about last night. You did a torsion problem, and
Can we talk about that?
I know and I want to say something. I got an email about it too. This might be from the same student, and I said, every time I teach simple harmonic motion, I always wrestle with, oh gosh, do I teach torsion? Because I think it shows up once or twice in the 35 years, or 40 years that we have tests for. So go ahead. What's your opinion about the torsion? I told my
Well, what did
student, I
the
said,
question
it is
say,
highly
Roger?
unlikely. Well, the question wasn't fundamentally about torsion. It was about force. So here's what they say. It says, I noticed that you yesterday's practice FRQ covered torsion, which I had not seen before in any of my physics classes, and Googling it yielded something very inconsistent with the problem. What would you suggest doing in such a situation where a student doesn't understand what the apparatus or principle is being used, especially in the lab design question? Good
Yeah.
question.
Well, one thing I want to say is I did make a mistake yesterday on part E. I re-videoed my response for 2, really the whole thing, because I just really wanted to redo it. As teachers and people in general, it's important to be able to admit when you're wrong. Minute I said it, I was like, I know that's wrong. But it was with that replacing a conducting sphere. But I re-videoed it, and it should be, I don't know if it is just now, but it will be, if not already. If you see me wearing the sweatshirt, then you're looking at the more recent answer. But if you see me wearing my blue shirt from yesterday, then you don't want to look at that, because I messed up at the end. But the way that was calibrated, the wire in that torsion apparatus was calibrated already using the arm R. So like normally when we look at torque, and torque is R cross F, and that can equal beta theta, but when we are normally looking at that, we're looking at one specific situation, and the R in the R cross F is important. But in that apparatus, the way that it was calibrated to find the beta was using that same R. And when you do the derivations, it ends up canceling out. So you don't have to take the R into account. They're looking at how they placed it this way and placed masses on top of the sphere. And they looked at the proportionality of the force to the angle. And so then we're still doing the same thing once now our 2 spheres are like this and they're charged. We're looking at the electrostatic force and that torsion angle and their proportionality. So the R in the R cross F is the same in both of those cases when they found the constant. So it didn't come into play. So when you're looking online, that's probably what you're seeing. But again, I don't want to get into too many specifics of that. I don't think you're going to see torsion on the exam this year. The things that you may see, though, you still may see torque. So in the first problem that we did on Wednesday and that you went over, Roger, on Monday with that dipole, and there being torque on it. I mean, I think that's something that's very doable. The torsion is a little bit more mechanics heavy, and that's not something that would come up. But if you don't know or don't recognize, don't focus on the equipment. Focus on the concepts. So if you have two charged spheres that have a force, and you're looking for a charge, then you should still be automatically thinking Coulomb's law. And what could you still do with that? Even if you can't complete the lab, like still just focus on the concepts and what things, seeing that apparatus, like could you pick out something that maybe you could measure or maybe you could change? What do you think, Roger?
I think that's a great idea. You know, think about if you see something that says that you're not familiar with, think about what does it remind you of, or what is it similar to? But I also agree with Kristen that I would think it's probably unlikely to see a torsion problem. I hate to say that on tape here and then be proven wrong, but that would be my
Yeah.
guess.
But
Okay.
go back
Well,
through
we
if you
have
do
another.
labs in class. Oh, sorry. If you do labs in
Go ahead.
class and you've got a lab notebook, that's something that you want to look through at least this weekend. What were the labs that you did, right? Because in electricity and magnetism, there really aren't that many things we can actually do a lab with, right? So go through and look, like what were those things that you did with circuits? You know, we can find resistance or resistivity. We can find the internal resistance like we did, or EMF of a battery. Like there isn't really capacitance with a capacitor. So electric field with plates, there's not really, you know, a whole lot that we can do. So go back through and look at those and just make sure you understand the concepts with those things and what you could change. Sorry, Roger, go ahead.
Well, yeah, so the next question we have, I think is a great one again. It says, what does it mean when they say without algebraic manipulation of equations? And I know exactly what they're talking about because this was on the 2020 C mechanics question. So what they mean when they say without, they don't want to see you manipulate the equation. So let's see, that particular problem, I really want to pull it up because it was so good. But I'm afraid I'll waste time if I do it. It was, oh my gosh. Hold on a second. Let's see.
Here, while you're looking for it,
so yeah,
I'll put my 2 cents in too.
Yeah.
So yeah, they just don't want you writing down a bunch of equations, because that's kind of the thing that kids fall into, and what colleges professors give us feedback of is that, yeah, these kids can plug into an equation, but they don't know what that means. So they still want you being able to connect concepts to math. Now, you can still reference an equation, but they want you to say what's going on with the relationships within the equation. So you can still reference Coulomb's law, KQQ over R squared. But if the charge goes up without changing the force, then the R must go up. Or like if you're changing something, they want you talking about the relationships and using those words and using the relationships, rather just falling into the, oh, well, if here's the equation and I manipulated this, here's my final equation.
Yeah. Hey, why don't you, can I go ahead and show them this one, Kristen?
Yeah, let me stop sharing.
Okay, great. Thank you. All right, so check this one out. This is what I'm pretty sure what the respondent is talking about. Okay. And so you can see here that we have, this is one of the questions that you would see in the mechanics problem. This was this year's mechanics. And it says students derive the following equation for distance D. D is equal to FLM over M plus M squared mu kg. Without algebraic manipulation, that's what they're asking about. Without algebraic manipulation, does it accurately match your explanation in part A? Well, in part A, I said that if you have a longer tube, then distance should be longer. So what they want me to show is that these two are directly proportional. So what we're looking for is, do you get the big picture? Do you get what it means when something is in the denominator? Do you get what it means when something is in the numerator? Also, it is so useful often to focus on the units. You know, if I'm going to look at a problem, again, you don't want to dive into this, you know, belly first, because there's a lot of units in here. But look, you've got a kilogram squared, right? And you've got a meters per second squared. And then up here, you've got a newtons, which is kilograms, meters per second squared times a meters times kilograms. So, you can sometimes use that to see, is that what they're talking about? That's that idea of without algebraic manipulation. All right. So that's what I wanted to show.
Awesome.
Okay. There's another one here, and there's more than one question about, should I copy and paste or write by hand? That is the question
And I
for
think we kind of have
2020.
different opinions on this, Roger. I personally
I think,
am a
yeah.
copy and paste person because you don't want your AP reader, and we're both readers, Roger, so we know where this can go down sometimes, that kids have writing all over and then they like need more space and they're writing. I mean, and it may not be because you're not confined to one space, but the writing can be hard to read. And I think that you're not going to get questions that you're really going to need to be handwriting. So I'm a copy paste person because it's easier to read that typed font than your handwriting.
Yeah, I have to say that I think it's going to vary from person to person. We have more than one respondent who says, I like doing it this way. Another one says, I think and the mechanics people are all about the typing. I think if it were me, I'd be writing, but it's going to be your call. I would suggest that you look at one of the videos from Monday or Wednesday when we did the mocks and just pause the video, look at it, and try typing your answer and see how it feels, and then try writing your answer and see how it feels. Because more than anything, you want to grease the slide. You want this to go as easily as possible for you. And so that could take a little bit of, experimentation. So don't be afraid this weekend as you're studying to study for maybe try a half an hour of just typing. Can you type physics? Can you communicate it? The kind of problems that we've been looking at. Yeah, I think that's my best go on that one.
Yeah. And if you are typing, like you can use shorthand, right? So where you have a word that might be longer or like theta, or I mean, that's not that long, but you can say that for everywhere in this equation, theta is going to be X. And you can just be writing X. You can create that shorthand as long as you are upfront with the reader on the problem, what that's going to stand for. Then you can use those shortened things to save some time. I think typing also forces you to avoid trying to use equations. I don't think that there will be questions where you will be writing out equations in your answer. I think it's going to be all kind of explainy, but you may want to reference some law in your thing, and that's fine. You don't have to. It doesn't have to be perfect. You can type up F equals K QQ over R squared, and then you don't have to have it be a perfect subscript. You can use the caret. It doesn't have to look like a nice, pretty equation.
Yeah, I think that really is good. This is not for you to create beautifully typeset equations that look really, really nice. This is for you to get your information from your head onto the paper as efficiently as possible. So please don't worry about the typesetting. Use your math skills to write it as easily as possible. Okay.
Yeah, I'm going to pop up while we kind of catch up on some of the questions, Roger, while you're looking at that. I'm going to pop the PowerPoint back up and show where they can ask questions.
Yeah, thanks.
And B, touch on a couple. I think that was pretty much all I had for the QQT problem on here. So again, if you have questions, we're answering them using the Google form here or the QR code or Twitter.
And I hope you're looking at Twitter, Kristen, because I haven't been looking at Twitter.
I am, but there hasn't been anything yet. I think that we have dated ourselves by using Twitter, Roger.
Okay, so here's a good question. It says, which Greek letters would it be most helpful to know how to spell? Well, epsilon comes up a lot in, E naught is epsilon. So that's EPSILON. Let's see, theta is THETA. I think that's a good one. Let's see.
You're not going to get docked on spelling though, so.
Yeah, you're not going to get docked on spelling. Sigma small sigma. So we have our, let's see, lambda, sigma, and rho. Yeah, can we write those out for them, Kristen?
Yeah.
RHO for rho, right? And then lambda, LAMBDA,
Oops.
and then rho, lambda, sigma. And thank you for writing them in the correct order. And so that's linear. That's lambda stands for linear charge distribution, and sigma, small Greek letter sigma, is area charge distribution, and small Greek letter rho is volume charge distribution. Let's see, epsilon is, we have mu naught I over, no, mu naught is for magnetism. We don't need mu in this E&M. Any others? I think that's it.
Yeah, and
For
I don't think you're going to have to use them too much, to be honest,
right,
because this
and
is equations.
remember that K is 1 over 4 pi epsilon naught. So it's a lot easier to write K, the Coulomb's law constant, than it is to write 1 over 4 pi epsilon naught. So that might make your life a little bit easier.
Yeah.
Okay.
And
All
you
right,
don't have
let's
to
see.
use those. You can say what the variable is. I mean, you can say the linear charge density instead of like using the symbol of lambda. You can say the area charge density. So let's look at some tips on the lab-based question too. So on that lab-based question, you want to kind of be analyzing that situation and looking at what kinds of equations or laws that you could use with that to determine what your unknown is, right? So if you were looking for a formula on the formula chart to fit that lab, I always kind of do that as my very number one step. Like what kind of relationships are there going on here? That you are looking at what could be varied or what's going to be constant in that lab. If you're given anything that you already know, what are you going to measure? What equipment are you going to measure? And we can talk about equipment too with this, Roger. We're using equipment that is commonly available in a physics laboratory, right? So obviously meter sticks and things like that. And with electricity and magnetism, we don't have as many as there are in mechanics, but you want to make sure that it is real equipment that you are using. I mean, this is more in mechanics of people who want to use like equipment that doesn't really exist, that you want to get these variables that you can't really just directly measure. You have to calculate from some way. But we have our meters, right? We have a voltmeter, we have amp meters, we have ways to measure the resistance. So what kinds of equipment could you use in the lab? And looking at, oops, that went back to the wrong one. There we go. How you could measure that, what you're going to vary to produce multiple trials. Always be thinking or assuming that you've got to do a lab where you're going to be doing multiple trials, and what could you change? What are you going to graph? So how do you linearize that data? So you get that nice either y equals mx plus b, or the way I like to rearrange it is where I've got y over x equals slope. And what is significant about the slope or the area? One of those two things is always going to be significant, or the y-intercept. Slope, area, y-intercept. What is important about your line? And what other assumptions are you making in this lab, right? So are you assuming that the wires have no resistance? Are you assuming that your meters are ideal? What are those assumptions you're making? Because when they throw that last part at you about this is changing or this isn't what you expect, that's usually where you're going to get those answers from, is what things did I assume that maybe aren't true?
Yeah, like, when we're doing problems and the teacher says, assume a frictionless environment. Well, we know that those don't occur a whole lot of time in labs. They occur in problems that we do in textbooks, or the classic is imagine a spherical chicken. Well, chickens aren't spherical, so you want to ask, what assumptions have I made? And if you've ever done a lab, when the answer comes out completely different than you were thinking of, that means you're measuring stuff.
Yes, exactly.
Kristen, I just want to talk to this. We did get a couple of questions about capacitors and charging and discharging. And that's a great question. We're not going to address that question tonight. You're going to need to go back and look at our daily lessons and go and hit those up, because we did talk about those in those lessons. There's some really good resources there also on the AP website. But tonight we're not going to go into the specifics. I apologize for that. But go ahead and rewind and watch our video about the time constant, about capacitors in series and capacitors in parallel, and hopefully that'll help.
Yeah, and you will not be deriving that equation for those things, but you still have to know that relationship and that it does take time for the charge to build up on a capacitor, and that's changing the current through the resistor at the same time. And like knowing those concepts and what's happening and what is going on in those initial conditions and during and at the end, and maybe they're going to give you a relationship for the charging of a capacitor or a function, and you've got to be able to analyze that and know how to go from a charge versus, charge as a function of time to current as a function of time, or current as a function of time to potential difference. So how you can go back and forth from those equations as well. I could see that easily on there. If you're given a charge versus time and they want you to say, well, how could you find the current at some time?
Right. I have a question that I just have to address, because I really think this is something that I don't want our students to try, Kristen. And it says, will you be able to print off the questions and submit a handwritten response from the same paper? And I just want to say, please don't do that. Because just think about how many steps that would take that are not doing physics. Okay. Now, the printing it off, I don't think that's a problem, because you can, if you got a good setup at your house and you want to print, that's easy, and you want to practice that ahead of time. But it's the part about writing it. Think about, you're going to write on these pages, which are not designed to be written on, by the way, because they're not set up with blank spaces like a normal page. So you wouldn't have the space to write on them. Then you'd have to scan that. When you scan that, you would get a JPEG, which you're not supposed to submit as a cut and paste or as an attachment. A JPEG is only supposed to be a picture. So that could mess up the other side of the technology. So, you want to think about the easiest way to get that information to AP, but I think the idea of scanning something is something you should not do. The most I would do is say take a picture of something, but remember, anything you print out is not going to have space on it for you to write on. Okay, that's what I wanted to say about that one.
Yeah, and really ask yourself, what are the benefits of that? I guess just that you have the question there, but other than that, I can't see a benefit of it. If it's not going to benefit me, I don't want to waste my time.
Okay. Let's see. Where can we find the best FRQs to practice this weekend? Well, AP Central. I wish one of the questions asked that, Kristen, and it says besides AP.
Yeah.
As AP teachers, what we have come to learn in a very short period of time is good questions, good old questions are gold. They are absolutely precious to us, because they tell us more about where we're going than any other piece of information. And so we use those, and those are the best things. And I would say, if you want to look at anything, go to the AP website and do the last several years of E&M FRQs. They're all there. They're all posted. Remember, you want to skip anything that's got to do with magnetism, and almost without exception, every E&M FRQ has one of the questions that's about magnetism. Almost without exception, you can throw one whole question away. Okay.
Well, and I would go back, and here's my plug for Physics 2. I mean, I would go back and look at the Physics 2 exams, because they are going to be in similar informative of the questioning, right? They're going to be those more explaining of things, predicting of things. Might not be at exactly the same level, but it'll give you some good practice at the writing. Or when you're looking at the old C exams, how could I change this question to where I'm still answering the same concept, but I am using words instead of just math?
Yeah, I think that's really good. Someone asks, if we were to scan a handwritten solution not printed, can we upload it as a PDF?
I think they
No.
have changed. No, I think they've changed it to now be able to accept PDF handwritten responses. I would
PDF
go
handwritten
on, yeah,
responses.
I would go on to College Board site, but I'm pretty sure 99% that they have changed that policy. In the beginning, they said no, but I think the latest is that yes, you will be able to. But I'll go online and make sure.
Okay, yeah. Now, someone says, how would I type a derivative? So can you give me the screen here? Because I want to show you guys.
Oh,
This
yeah.
does not have to be rocket science, folks. This is really, this should be easy, and AP wants it to be easy. So if I'm typing here, let me pop my screen open and show you something. And I'll just pull this up. All right. So if I'm typing and I want to type dy dx, a derivative, I'm going to just type dy slash dx, and it's just going to go in like that, and that's okay. So just doing this is going to be fine, even though the first one is big D, because the reader is going to look at that and go, oh, that's a derivative. Okay. Or if you want to type, an integral, the integral of, right, just how you would do of velocity, right, from t equal, and see, you can really type this really fast. And so that's how you can easily communicate your math. And so you're going to say that the integral of velocity from t equal 2 to t equal 5. You don't have to say dt. You don't have to, we're not going to hold you for all of the little particulates of the calculus. We want to know, can you show us what's going on? And even this, I think, might be more mathy than we're going to see this year. But if you had to say something like that, that's a pretty easy way, I think, to do that.
I
Okay.
think it's really important that you said those limits on there, because that's always usually points on the AP exam, right? What
Oh,
integral are you
yeah.
taking with respect to, and what from where to where? What are your limits?
Yes. Yes. And that also reminds me of something that I think we see more, Kristen, in physics, in mechanics, but also it shows up in physics C. And that is this difference between, differentiating with respect to T and differentiating with respect to R, or distance. And so, you're going to see this comes up a lot. And when we're, usually this shows up when we're doing potential or energy, because remember, energy is never about time. So there's no energy here. All right. And so this is usually potential. That's an important thing to get. But again, when you're writing a derivative, we're not going to, the integral, we're not going to worry about that piece so much.
Yeah, I just saw a good question, Roger.
Yeah.
What are some things we can always do to ensure that we get some points when answering a problem?
That's a great one. Well, you've been a reader, Kristen. So, and I think, and I've seen many questions that don't get 1 out of 15. So how can we help them get some points?
Use your physics words. I say that all the time. Use your physics words that are actual terms, right? So current, and trying to think of just EMM ones, right? Don't just say it moves. How does it move? This can go for a charge in an electric field, right? It doesn't just move, it's accelerating in this direction. What's happening with the velocity? Be specific, use your physics words. And I would say try to answer, even if you're just going to start with a basic concept for every part, right? So you don't want to waste 20 or 18 minutes on part A because you want to get every point on part A and you've lost points on the other one. So I would say don't spend more than a few minutes on every question in the initial part. Jot some stuff down that you know is going to be going on, and then you can go back and fill in the rest of it later. But try to at least read and try to do every part. And I would read every part before you even try to answer anything. What do you think, Roger?
I think that's a good idea. Read the whole thing, and read it very carefully. I know that probably a third, no, more than that, half of my errors when I make mistakes, because I do a lot of physics problems, you might imagine that. When I make mistakes, about half of my errors are reading errors, not reading exactly what it is. And I even got an email from one of my teacher colleagues who said, why would this be wrong? And the the graph that the teacher had drawn was absolutely correct, but it wasn't what AP was asking. They didn't ask for the right graph. They said, what's wrong with this graph? So you got to really look and see what it is. And here's another thing. Not every question has an explain. Don't read the explain that's not there or the justify that's not there. There are 1-point questions, clockwise or counterclockwise, yes or no, less or more. And so many of them, as a matter of fact, most of them have justifications, but some of them don't. So please do not give more than is asked. You'll be wasting your time.
Yeah, I think this year we probably won't see many without justifications, but yeah, you don't over answer a question because you can talk yourself in circles and out of points.
Yeah, I would also say, as far as getting that 1 point, look for those relationships again. Is it an inverse relationship or a direct relationship? Are the two things in the numerator, or is one in the numerator and one in the denominator? Is one thing squared and one thing not squared? We know sometimes, when we double the distance, we cut the force in a quarter. So that's an inverse square relationship. Those are the big ideas that really are going to make you stand out in this test, is understanding the big concepts and less those particulars.
Yeah. And that's what Ben from Michigan is asking. Can we lose points for writing wrong equations or concepts if we contradict ourselves? And that's where we're told very specifically at the reading is that we read the most wrong response, right? So yes, you can lose points if you are writing bad physics.
Yeah, please try and use be as clear and concise and direct as possible. The clarity of the physics is very important. And I also wanted to echo something that you said a minute ago, Kristen, is the idea of pronouns. And we deal with this all the time. When you say, and you're talking about something and you've got a 2 or 3 sentence, sometimes a 3-sentence explanation, and you say it decreases, well, what's the it that you're talking about? Are you talking about the slope? Are you talking about the velocity? Are you talking about the derivative? So be careful about the term it or the function. Say exactly what you mean, and that'll help clear up any inconsistencies or anything that's unclear. There's a question here, Kristen, about rank values. It says, for a question where we rank values, if some but not all are in the correct order, do we get points? And I think the answer is sometimes.
Yeah, I think it all depends on how the rubric is written and how many things you are ranking. So if it's just is Q1 bigger than Q2, generally there is not a point for that. We do not give points for a guess. So if you are doing a checkbox, there are no points associated with the checkbox. So saying Q1 is bigger than Q2 is not going to get you any points. Where you're going to get points is in your explanation. Now, whether we read the explanation sometimes does depend, though, if you checked the right box. So not always. Sometimes you can still get points for your explanation, even if your checkbox is the wrong checkbox. Kind of depends on how many of the points there are. If the justification is worth 2 points, then sometimes you can still earn 1 point if your checkbox is wrong. But if the justification is only 1 point, then a lot of times we kind of are told that you can only earn that point if the checkbox is correct.
Okay, Kristen, I think this one is a pretty good one. And so this one says, for the equation relationship problems, if the equation is incorrect, but one part of it is consistent, and the question is this equation consistent with the above description? Should you consider the whole equation or just the part that's described? I would say usually AP is very clear about this, and it'll say, if an equation is wrong, if part of an equation is wrong, the whole equation is wrong. You can't have it be partially wrong. But if they say, for instance, what part of the equation is wrong? Well, if you look at the constants and they're the same, well, that's not that. But the problem that we were looking at from a few years ago, where we had, I think they had an X instead of a Y instead of an X. Well, they got the geometry wrong. So that's what they were looking for in that one.
Yeah, and I don't think they're going to do that to you where they're going to have just part of it be wrong and you're just saying if it's wrong. I think it's that same thing. They're going to say either what parts of this are correct and what parts are wrong, or what parts of this equation are consistent with what you were saying and some other part, not just is it consistent or not.
Right. So before we tie this up, I did want to, I don't know if you saw this, but one of the respondents asked if we would give a shout out to their teacher. So shout out to Mr. Khatib. And the students, Kristen, are saying that it's his first year teaching both AP Physics C, Mechanics, and E&M, and he's very invested, and he's put in so much time to help you learn. So that is a wonderful shout out to Mr. Khatib. You've got some really supportive and loving students.
Yeah, that's awesome. That's a hard, especially this year, situation to be in.
Yeah, I feel for you, Mr. Khatib. This is a hard year to be your first year. So look forward to better, more consistent years next year, hopefully.
Okay. Well, Roger, what are your last final pieces of advice here?
Well, are we going to show them the video?
Yes, we will.
Okay. So my last advice to you is, do what you can this weekend. I don't think you should take the weekend off. I think you should do some FRQs on Saturday. I think you should do some FRQs on Sunday. And I think you should try and get together with another student. If you can do that, Skype, Zoom, FaceTime, whatever, we know that the human brain learns so much more when you're in conversation, when you're working together with someone else. So get on the phone, work some problems, and then work some more. And you will find it's going to come to you. That's what I got.
Okay, I agree. I think get rest, try not to stress. You guys have worked hard all year, and especially these last 2 months. So you're going to be okay. You just have to trust that you have got it. I think that everybody's in the same boat this year. Everybody's being compared to each other. So you are not being compared to last year's students. You're only being compared to this year's students. It is going to be good. You have got it. And yeah, just go back, look over your stuff, but don't obsess about it. Don't spend too much time. You have got to walk away. You've got to relax and trust that you have got it. So we do have a goodbye video. I, again, just want to say thank you so much, guys, for tuning into us. And to my students, you've got it. It's awesome. It's all going to be good. And I can't wait to see you maybe sometime this summer before you go off to college. Roger, you want to say anything to your kiddos?
We'll see you before the year's out.
Okay, I'm going to share.
Make sure you share the sound too.
Yes, a video that is just kind of a final video that College Board has put together of all of these lessons that people have been doing. And this is just kind of our take it home here for you.
We are live.
So we're going to walk you through everything you need to know and you're going to have it. And so, may the 4th be with you.
Continuiamo anche il nostro giro per l'Italia.
You Are Local Lunatic shared this via Twitter. I'm really, really grateful for @JacobsPhysics and @Mr. JB Physics and just @College Board in general for doing so much for these AP exam reviews. I actually get stuff a lot more than I did before COVID happened, and I'm just really, really grateful for that. Smiley face.
All right, so we're talking about the overall big picture of period 4. Here are some things I just want you guys to remember.
KOA shared on TikTok, AP English Zoom streams are my only social interaction right now. #FYP, #isolation, #AP English.
They would send large ships of laborers just to collect the guano and get on the ship. Is collect the right word? Do you mine guano? Do you excavate it? I don't know what the verb is there. I'm supposed to be using.
And we're going to be focusing on tone. Specifically, how do you read and interpret tone?
Karen Tabola Moore on Facebook shared, my students have enjoyed the AP Latin videos with Jeannie Luangu. Since I can only give a live Zoom class twice a week, this has been a great support.
Or I could say I want my lawyer and they have to get me my representation. But, and here's our but for today, that is going to sacrifice the abilities of the community.
Am I sharing the slideshow right now?
Nope. Nope. If you are, I can't see it.
Utkarsh Kali shared on Twitter, "Thank you for the helpful AP classes on YouTube. My preparation for AP Calc VC has become so much easier and efficient."
So I drew this like 4 o'clock this morning. So it's not beautiful, but I think it gets the point.
You turn over another card and they get compared and that person would win. Tell me if you do it differently, Mr. Schultz.
The more that you can find that connection within yourself, within the character, I feel like you write the character with a lot more depth.
Learning about the economy is important, and I wish more people did what you're doing.
My advice to all the students out there, whatever it is you choose to go into, make sure that it's a passion that burns in your belly.
I learned so much working in local government about public service. It teaches you that it's 24/7 and that you have to learn to listen.
I am someone who believes in following your passion, right? And working hard. And if you kind of find that there's something out there that you think is a need in the market and no one else is making it, then maybe you have to be a little bit creative.
11th grade US history is the reason we're talking, because I don't think I would have picked up Ron Chernow's biography of Alexander Hamilton if I hadn't written a paper on Alexander Hamilton in high school.
Asia K3 shared on Instagram, "I'm so glad he came. He's the reason I was able to get more interested in US history, and I always listen to the Hamilton soundtrack when studying for APUSH." Emoji.
We have a message here from Girleen from Instagram. She says, "Definitely worth waking up before noon."
And so you just connect your battery to your magnet like this, and then you get copper. Ta-da!
Look at that. That's amazing.
When are we ever going to need calculus? You'd be surprised. I mean, you might make videos and then calculate like the breaking pressure of Thanos' abdomen if Ant-Man were inside it.
Shout out.
This one hit close to home. This is very special for me. Mr. Walters teaches in Managua, Nicaragua, and that's where I was born. And I want to say hello to all the students out there.
Lyra Matt tweeted, "I watch every AP Lit video. They're so helpful, especially for students whose first language is not English. Ms. Barber and Mr. Carter's enthusiasm and passion inspired and encouraged me not to give up."
Miren, Julia de Burgos nace, es todo un mito en la littérature caribeña.
Pour souligner encore ce qu'on essaie de faire, on veut expliquer des idées et des opinions.
Mrs. Lowe shared on Twitter, "These videos are excellent. They do a great job of reviewing mixed material with an awesome job of presenting new material."
好，下面是 cultural presentation。抱歉让大家坐着哈，但是这个很重要。
今日も一緒に日本語頑張って勉強しましょうよ。はい、それで。
Chanel Kernander said on Twitter, "Love Mr. Escobar and Miss Barber's videos for my AP Lit students. You two are awesome. Tuning in live from Houston, Texas."
What'd you say for Dabo? Did you answer what that means?
Yeah, future. I will give.
Just as Gandalf parted ways with the hobbits before they undertook the scouring of the Shire, the time is almost here for Josh and me to sail into the West.
Thanks for showing up every day and reviewing the course with us. And remember, on the exam, sound like you've taken the course. Be specific and be scientific.
It's been a blast working with you all spring. And like I said, this chapter of your life isn't over. You now have a chance to rewrite.
Thank you so much for watching Mark and me for these last 30, I don't know, however many sessions we had. And if it weren't for you, we wouldn't have had these sessions.
Well, thanks for watching. And one final piece of advice. If the question seems really complicated, it's probably not.
Gracias por haberme acompañado durante estas semanas.
I just want to say thank you to all the amazing AP Statistics students out there that have been following along with us for the past 6 weeks.
Thank you so much for watching. We really appreciate it and hope these videos have helped.
Hearing from you and seeing the pictures that you've sent us of your pets, thank you so much for tuning in.
Thank you to everyone for watching, for tuning in, for continuing your educations. Best of luck on your exams.
You've prepared, you're ready, do your best on this exam, and then congratulate yourself no matter what you get.
Optimum Fortunam Omnibus. Best of luck to everyone.
Thank you for tuning in to all of our AP Bio review lessons and our practice exam.
Bon courage, as we say en français.
Thank you so much for tuning in. Luke and I really had a super fun time, and we hope you learned a lot.
Thank you to all of the AP Chemistry students who watched the videos.
You're good enough. You're smart enough, and gosh darn it, people like you.
Thanks for tuning into all these videos. Music theory friends, don't forget to resolve your tendency tones.
You guys have got this. Remember, you are the solution.
Thank you so much for joining me the past month and a half. It's been such a journey and such a treat for me.
Hey, thanks for watching the last 6 weeks, especially the calculus crew.
You guys are awesome. You are excellent. You are brilliant. I really, really enjoyed our time together, and I know you guys are going to rock that exam next week.
Just remember that you have worked your butts off this year. Y'all are going to do great.
It is time for you to shine.
Type your response, copy it, paste it in the submission box. Good luck.
Hey, arigato. Thank you. Ganbatte kudasai. Remember to practice on the app that comes out next week.
Y'all are going to do great. And remember, geography is everywhere.
All right. So folks, that's all we have. So Roger, I've had so much fun doing this with you. It's been such a joy to work with another physics teacher every day. So I want to thank you for being so awesome.
And thank you right back to you, Kristen. This has been wonderful and couldn't have had a better partner. Thank you, AP students, for working so hard, for loving physics. Go out there and take everything you know. You're going to do great, great, great on Monday. Kristen?
All right. Good luck, guys. Take care.